Third session after lunch, back to back. My apologies. So, data observability, I think before we go into the details of data observability, the way I have planned this session is to share my practical experience with data observability. Because there's a lot which you can Google and you can figure out what's there, how do you define data observability and how do you use it. But I wanted to have two perspectives in this session. Bring those two perspectives. One is that what does data observability 101 is, like the way we define, the way we implement, and the way we realize the value from data observability. And second aspect is that out of the box definition implementation can give you value to a certain level. Beyond that, we have to be innovative in terms of how do we implement the concept of data observability. So that's the whole premise. So I hope that in next 20 minutes I'll be able to share some valuable insights from my experience. But one thing before we start, like if we split data and observability has been around since we started building the systems. Right? When we build a system will have bugs, system will have errors, system will have issues, system will emit the logs. And when system emits the log, we want to read the log and we want to take action in case there is a failure. So that's the very basic 101 type of definition of observability. So observability has been around for many, many years. Data has been around for many, many years. Right? You just saw the previous session where we talked about many of the logical data definitions in terms of feature store, data warehouse, data lake, and all, and they have been around for 30 plus years. But still, data observability is relevant now. If you go to trends.google.com and you search for data observability, you will see that in last 6-7 years, that keyword has trended. Before that, it was not there. Though data was there since more than 30 years, observability has been there for more than 30 years, maybe more than 100 years. So, interesting thing is that earlier when you talk about data, shape of data, it was mainly the tech stack was mainly commercial, right? You have a big box of database, call it Oracle, call it Teradata, call it Netezza, call it whatever. Then you have a big box for the data processing. You call it Informatica, DataStage, Talent, Pentaho, n number of options are there. Then you have set of boxes for consuming the data. You have say Tableau, business objects, you have Cognos, n number of technologies. So within these boxes, we had this observability built in. So systems were not talking to each other because there was no need. There was an administrator for each and every component. But now, fast forward, say since last 10 years, when the big data became mainstream, open source became mainstream, so system became distributed, data platforms became distributed, and people are going for the open source. That means they have to manage a lot of things on their own. And one monolith, one big box is now a set of multiple boxes which are talking to each other. And for us to realize the value of data platform, unless these boxes are talking to each other in a coherent manner, we will never realize the value of it. So hence the data observability in the current times has a very different set of challenges. So let's get deep into it. But before we get into what data observability is, if you just think about what comes to your mind when you think about data observability. I have set the context about data. I have set the context about observability. So if these are the things, if that's a sort of word cloud which comes to your mind, that what will data observability look like, right? When I say, okay, I have data observability in my organization, what do I mean? I mean that we have a lot of monitoring, we have a lot of dashboards, we have alerting, we have monitoring, we are looking at the quality of the data. At a high level, this is what the data observability looks like, right? We have set up bunch of alerts, and we have dashboards to look at the health of the data. And if anything goes wrong, we get into the root cause analysis. Okay, why there is something, why the data is not making sense. So from capability point of view, I think some slide got I think some slides got messed up. Can you call the person? All right, I think sorry about this. Okay, something is okay. I don't know in what sequence the slides are now, but this is the slide I wanted. I think either there is some delay or I don't know. No, we are good now. Right, so we're looking at the word cloud, that what all comes to our mind when you talk about data observability. And typically in any organization, you will have such dashboards. You may have very different set of technologies. You have Grafana, you have Prometheus, you have Victoria metrics, you have your own set of event logging. You have, you're logging all these events in the databases, and then finally building, alerting, monitoring on top of that. Now, one important thing here, if you notice in the slide, is what is the outcome we are looking for from all these metrics, dashboards, and everything, right? Typically, and ideally, it is that whether my data is trustworthy or not. So, as an organization, I may have 20,000 tables, 10,000 pipelines, 500 dashboards, 10, maybe 50, 100 databases, and hundreds of users. As an organization, how do I measure the maturity in terms of data health? Let's not call it data quality or data observability. How healthy my data is. Ultimately, all the observability has to boil down to this. When we talk about observability from the service perspective, we talk about P99, P95. Right? That's a single metric which defines the quality of my service and availability of my service. But what about data? When we talk about data, we say, okay, my success rate for my pipeline is 98%. We talk about if there are 1,000 queries running per day, out of that, only 5 are failing, remaining are successful. Whether my data is available or not, the lag in the data, it is lagging by half an hour, 1 hour. So all these are independent set of metrics. So how do they come together in the form of the data quality or data health? So we look at that. Okay, this is seriously very sorry about this. I don't know why it is. All right. Right. So, what we were just looking at, that we build in terms of the capabilities. We build this monitoring. We build these dashboards. We do all this root cause analysis, just to ensure that there are certain metrics which my infrastructure, like if you see the bottom of the slide, the whole observability in the current state, the definition or the key impact what the observability tools is trying to derive is telling me the health of the infrastructure, my data infrastructure, how my pipelines are running, how my dashboards are running. But is that the true value we are looking for from data observability? So, what are the key tenets of data observability, right? When we say my health of data is good, it is like 97%, 98%. So there are n number of ways we can define that if I do these 10 things right, if I start monitoring these 10 things, this will define the health of my data. So I have just mentioned which I think are important. Quality of the data. Now quality may have a different perspective from different persona perspective. For some user who's a business user, who's running a campaign, and they want to see the data in a near real time. For them, the quality in last 5 minutes of data is good enough. But a data scientist who wants to take the historical data and run some models on top of that, for them the definition of data quality is very different. But the important thing is, how do we define the quality, right? So going back to the previous slide where I was showing that 97%. So one way that we have translated the actual, say, technical metric in terms of what is a data quality at the org level is, what we do is we define, say, let's take Slice example. Right? Slice has 3 main products. Slice has Slice Borrow, which is lending product. It is Slice UPI as a UPI product. And there is Slice Account, which is like a prepaid wallet with a credit card which you can use. From quality perspective, each of these products are ultimately set of services, and these services are sitting on top of the databases. They have multiple schemas. Again, in the databases there are tables, and tables have the columns. Now, what we do is we define the weightage or the priority from the business and the product perspective. That this, if I had to define data quality for Slice Borrow as a product, then these are 10 schemas which have to be always pristine. Remaining can are like less in terms of the weightage, right? Now for those schemas, what are the key tables? Transaction tables are important, user tables are important, account table, payments table, settlement table, ledger. These are the key to the business, which define the health of the product. So those are important. Rest can be like lower weightage. Now within those tables, not everything is important to us. So we define the weightage at the column level, at the attribute level. Say, if these 20 out of 100 columns are in good quality or good shape, then how do we define? Is by set of rules defined on top of these. Then we say, okay, my Slice Borrow today, health quality is 98%. When I double click, I go to the schemas, then it says, okay, these two schemas are actually at 95%. One is 99%. You go further down, you go to the tables, you further go down, you go to the columns. And when you bubble up everything, it gives me one 5,000 feet view of what the quality of my product is. And if I can roll up across the product, it gives me the quality or health of the data at the say org level, at the Slice level. So again, on the timeliness, quickly I will go through this, because I think this is something, if you Google, you will be able to relate to it. So I will not spend much time on it, but rather I want to spend time on how differently we are doing things. Timeliness is about the lag. The metric which we track for timeliness is lag. We have a lot of near real-time use cases where we want to do the intervention in case there is a fraudulent transaction. For that, we need 150 milliseconds of latency. That means from that user is trying to do a transaction, and we should either accept or we should deny that transaction within that 200 millisecond. So in case if we have more latency in the data, then definitely we will not be able to make the right decision over there. So timeliness is mainly about the lag in the system. Availability, there will be different definitions of availability. The way I define the availability and the way we have implemented availability is whether for a different use case, for a specific use case, for a set of persona, whether the data is available for access or not. For example, if a new user comes in, if a new person comes in a certain team and all, do they have access to certain data or not? If somebody as a data scientist want to run a model on a certain data, which is a PI, non-PI data, so whether they have access to that data or not. There are some critical P0 reports, dashboards, metrics which need to be enabled. So do we, is there a problem in the system which is preventing users from accessing the data or not? So if users are not able to access to the data which they are entitled to on time, that's a big problem. So that is one metric from the health perspective. So no matter data with good quality, it's all fresh, but people are not able to access it. Integrity is, since we are living in microservices world, in one flow there are maybe 10 or 20 microservices which are coming into picture. For us to make sense of the data, we need all this data need to land in a certain manner. So integrity is all across. It is all about how different services are pushing their data to the system, and whether we have the right amount of data to from different sources to make sense out of it. Lineage, I think lineage, I don't have to explain. There was a question before this on the lineage. So these are the sort of key tenets for us to say build a good observability framework or architecture in the organization. But if you see, right, the metrics we are talking about, it's about success rate, pipeline, data quality, lag, somebody having access or not. One system is pushing data, other system is not pushing data. From business point of view, still it is not giving me that level of trust. See, what if one pipeline has failed? What if there's a lag in 2 pipelines? What if new user has come and they don't have access? So there are n number of problems. Holistically, still it is not solving. So data quality, if you go back, like initially, it used to be top 5 problems why people are not able to use data effectively. Even now, if you go and check biggest challenges for AI, it is still there. Data quality for machine learning, for data scientists, data quality is still the problem. So lot of tech has evolved. Like we have started from the BI reporting to now Gen AI, but still data quality remains to be the problem. So are we approaching data observability in a right manner then? So that's a question which we should, which at least I ask when we think about that we need to make investments, engineering investments, platform investments to build trust on the data. So how do we build that trust? I can build 50 different dashboards, hundreds of alerts, data quality alerts, failure alerts, but in my experience that has not been enough to build that trust. Right? So same thing which I was saying, right? We are putting a lot of effort across all these tenets, and there are many more. Like if you just search, you will see people are talking about 5 pillars, 4 pillars, 9 pillars, and hence the discussion talk is all about the nth pillar, that there is no end to the different tenets we are adding as we are learning more and more. So ultimately, for driving business value, what does business care about? Business care about the revenue, the money, the experience, how people are using the product, how are they loving the product, how they are doing good or bad compared to the competition. And being a fintech, security, compliance, regulatory requirements are non-negotiable things. Right? For us at least, this is how we say, okay, if I am investing 100K per month on data observability, then what metric from the business perspective I want to drive. So, because data observability is not cheap, right? If you search for cost and observability, these 2 keywords in Google, you will see on top 2 or 3 tools will come which will say, okay, we can tell you what the cost is. But what they're telling you is how much you're spending on S3 versus EMR versus this is this. The rest of the links will be how to reduce the cost of observability. Right? Observability itself is a quite significant investment. So now we are almost in the middle. So rest of the session I will spend on what we are doing. So it's not about tooling. It's not about we have different tools, we have built homegrown frameworks, but it is we are leveraging all the tenets which I talked about, data quality or availability, freshness, timeliness, integrity, and all the tenets are there. But how we are going one step ahead, which is closer to the business metrics, closer to the objectives what organization has, to leverage these basic tenets and build layer on top of it. Okay. Okay, so slides are messed up. So this is a slide I want to talk about. Business observability. Right? Business observability, it's all about key business metrics. It's all about, and business metrics typically do not move in isolation. There is always, if one metric is moving, it is, chances are very high that there are other metrics that are also moving. So that's why a lot of effort analytics team spends in doing the driver analysis. So driver analysis is all about finding the correlation between the metrics. Like if you want to move NPS as a metric, for that, like if I take e-commerce as example, because this funnel is an e-commerce funnel. Right? If I take e-commerce as example, then just to increase the NPS, I need to improve the order to delivery time. I need to reduce my cancellations so that people are liking the product. I need to give the better user experience in terms of it should take least amount of time for user to search for the product. I need to give the better selection at the different price ranges. So each of these each of these levers which I'm talking about, it's a metric in itself. Like fulfillment team, supply chain team will track the metric, which will be my O2D, order to delivery metric. Similarly, the selection team will track the metric, which is out of stock metric, how many out of stock impressions happened. But these are all different engineering teams. They are not talking to each other. But from business perspective, if my money is on the conversion rate, right? If my money is on the conversion rate, then what all metrics have to come together to make the conversion rate high or low as per the plan. How it is different from other dashboards we have, right? Everybody has executive dashboards for L0 metric, L1 metric, L2 metric. Thing is, L0 metric is operating at one layer of abstractions. That's why it is called L0. Then there is a L1. Then for each L0, there are certain L1, L2, and L3s. So what this view brings is that it brings all the metrics which are related, and it becomes very easy for the business to say, okay, if my conversion is going high, what else is driving the conversion up? And if it is going down, then what are the other metrics which are driving my conversion down? So there's one business view which tells me, okay, all these metrics, what is the correlation between them? Then under the hood, it is the user experience, right? Under the hood, the metrics are driven by the product experience. So product experience, like this particular funnel, it talks about this particular journey. It talks about for us to disperse the loan, approve the loan, there are n number of things which have to happen. There are n number of services which have to come together. Like for us to take a decision, we need to look at what's the credit score, credit worthiness of the customer is. For that, we need to get data from TransUnion. We need to get data from there are various attributes or signals which we have in-house. If the customer or the device is already a customer of Slice, if it's a new device, then we have other ways of finding those signals. But then there are external attributes which have to come together. Now, in this whole flow, right? In this whole flow, there are n number of services which are coming together. And suppose, as a business goal, what we have decided is that we want to improve our approval rate for the loan by X%, and the approval rate is not increasing. So how do we know that where exactly things are going wrong? So each of these services are maintained by different teams. So everybody has their observability of their own, where they are looking at what is the P99, P95, how many errors are happening, and if their service is healthy, they are happy. But if their service is not healthy, they don't know that what exactly the business impact it is creating. They will know that, okay, there is some downstream impact, but whether it is hitting the approval rate, whether it is hitting the onboarding experience, so what exactly is the problem? So we have this product observability dashboards, near real-time alerts and all. So where we stitch all these different services which are very much aligned with the product experience, which gives us almost near real-time insights in case something is breaking. And we are able to get other teams which are required to be involved in case there is an incident. Okay. So cost observability. So I think it's self-explanatory that cost is everybody is worried about. A lot of people are moving from data platform choice A to choice B because B is cheaper. And a lot of people are going to the open source from the managed because open source is supposedly cheaper, right? So in my past 2 companies, we moved from one managed to another managed to another managed to open source. In Slice, we moved from managed to open source, completely open source, and we were able to reduce the cost by almost 50%. Almost 50%. But with the open source, the problem is it's all distributed system. Right? It's not like one managed platform which gives you that everything, like you have your own set of dashboards and everything, you can just look at it. So what we have done is, though we have as part of generic observability, we will have all these metrics coming in, which is telling me how many queries are running, how many pipelines are there in the system, and what is my different service level cost, storage cost, compute cost, and we have different type of clusters running batch workloads, real-time workloads, what their cost is. But say, on a one fine day, the cost goes up by $2,000. Right? So how do you go about debugging that why my cost is up? So if you are on AWS, or I don't know about GCP much, but on AWS, if you have to see, okay, last hour my cost is suddenly high. First of all, you will not be able to get alerted if the last hour cost is high, because there's a lag of 36 plus hours when you get a cost from the AWS, right? So you're already blind. So we have built the observability where we mine the logs. Mine will be like over ambitious term, but we process the logs. We process the logs to look at, there are some, you can say, derived metrics we can use. For example, compute hours. So that tells me the number of cycles instance has been used. So based on that, we are able to compute in the near real time the overall cost based on the type of the instance, because that rate card is available. But then there are many other aspects of the cost, anomalies especially. Say I have just marked number of queries, access API cost, and data growth. Data growth is if you're on AWS, I'll take example of AWS. So for storage, you have two type of cost. One is the cost of storing the data. Then again, that cost depends on whether you are on hot, cold, glacier, blah, blah. And then there is a cost to read the data, access the data. And data access cost is typically higher by, it is at least 60 to 70% of the overall cost. So we had this incident where, so what happens is that if you have some certain schema, certain table, which has a lot of files, and you will be charged based on the number of times you are hitting, because your access API, your get object cost will be very, very high. Today, say for 1 month, this particular feature is still in beta. It is still running on a very, very small cohort. But when you do the launch to the rest of the world, then suddenly there is spike in the data. Then suddenly there is spike in the access pattern, right? So there are these metrics are lying all over the place. But how do you do the anomaly detection? For that, we need to understand the nuances of the distributed system and say, okay, my cost of API cost is related to the number of times somebody is hitting, also number of objects somebody is hitting. So I should track the number of objects so that I'm able to correlate these metrics. Otherwise, when this incident happened, we had one incident. It took 2 days for us to do the root cause analysis, that why this cost went up. Right. So, and by building all this observability, we have been able to figure out what are those pipelines, tables which nobody is using. So shut down those pipelines. We have a streaming real-time pipelines where the cost is pretty high for those, because they are up and running 24 hours. So if there's no access to that, so we should shut down those pipelines. So we have observability on the usage side, how many times a big table with lot of number of partitions, lot of number of files is being hit. So all that observability built around the cost has helped us reduce the cost significantly. Platform observability. Again, it's very similar to the cost observability. That platform is emitting the logs. It has those logs have various type of data. You can use the logs. You can leverage those logs and extract the metrics out of it to see, okay, how efficiently I am utilizing my infrastructure. So that drives the cost reduction. At the same time, you can use the same metrics to in case there is an anomaly, some job is taking 1 hour every day, suddenly it started taking 6 hours. So how will you go about figuring that out, right? And when I'm talking about distributed system, in our system we have Kafka, which is standard for ingestion. Then we have Spark, we have Flink, we have Ranger for security, we have Apache Trino and then we have a query book, we have a superset, and then we have open metadata for catalog. So there are n number of systems. Any endpoint can cause the number of queries to go high, and but number of too many number of queries on a certain table or a object is not always the cost of not always the cause of a slow performance. It could be that number of files have increased or something has changed in the fundamental, the way data is structured. So those kind of challenges, again, if you look at something in the isolation, it's very hard to figure out. But when we understand the system as a one system, then it becomes easier for us to correlate all these alerts and metrics. So these are some of things. These are like very few set of metrics which we are tracking. For example, if a job is failing, you may realize that your instance group, there is a certain type of instance which is being hit, but that there is a spot loss for those instances. You may want to change your node groups and all that. So a number of things which, so failure may not always be failure for because of memory and all, which typically we think is could be the root cause. So this I will cover very briefly. This is something which we are still working on. So with Slice being the fintech, there's a lot of as I said in the beginning, that compliance, security, regulatory requirements are non-negotiable for us. Though we have the framework to say, okay, who has access to what, how do we handle PI and all that. At the same time, we are building observability on top of it, where we know, okay, who has access to what and who has access to what, how they are using it, how many times they are using it, and what they are doing with the data. Are they taking the data out? Are they keeping the data inside? Is there any anomaly in the access pattern? And there are a number of things we are doing as part of the challenge, which becomes is that today your data, the way data access is controlled, the way your SSO is or Active Directory is maintained, and the way the organization hierarchy is maintained, these are very different systems. Some analyst may move from credit risk to onboarding. So he or she should have access to very different set of attributes or different set of metrics. But how do you marry this org hierarchy or grouping with your Active Directory SSO or with your data access policies you have? So that is what we are building as part of. Individually, all these components, they exist. But in totality, as a coherent system, that is what we are currently in the process of building, so that no matter a user moves from org 1 to org B, somebody comes, somebody leaves, whatever they do, even though they are running queries from the system account, like if you schedule a query, it may run from the system account, but we are able to track it, okay, which actually the user is through which the data is being accessed. So all this as part of governance and compliance observability we are doing. So just to end, there are different ways. See, when we look at the observability, right, data observability, as I said, one way is that you look at the basic implementation of alerting, monitoring and all. But it is very hard to justify the value from data observability unless it becomes, unless it is very close to the business problem, unless it is very close to the metrics as organization we are driving. So this is what we are working on. At the same time, we are looking at on AI side of things. When you talk about AI side of things, we talk about trust, we talk about ethics, we talk about biases, we talk about interpretability, we talk about explainability, bunch of things are there. We are not there yet in the sense that we do not have those problems right now, but the problems which I shared with you in terms of business, product, security and governance, cost, platform observability, these are the few things which we have built on top of your standard observability definition. Thanks.